first thing we need to do today is think about x squared equals negative 4. If we had the equation x squared equals negative 4, we would solve this by taking the square root of both sides. What is the square root of negative 4? But 2 times 2 is positive 4. But negative 2 times negative 2 is positive 4. But you can't, when you square something, you have to multiply it times itself. You can't do positive 2 and negative 2 because that's not really squaring something. So what number squared is negative 4? There's no such thing, right? And if I try to do this in my calculator, square root of negative 4, error, non-real answer. So in math, a long time ago, they found out that this isn't possible. You can't do the square root of a negative number. But there are some applications, particularly with electricity, where you need to be able to take the square root of negative numbers. Like it's necessary to complete the math. So they decided, let's make an imaginary number. Let's make a number that doesn't actually exist that we can use for square roots of negative numbers. So they decided that I is the imaginary number and I is the square root of negative 1. So if I have something like the square root of negative 81, I can split this into the square root of negative 1 times the square root of positive 81. Do you all agree that negative 1 times positive 81 is negative 81? Okay, the square root of negative 1 is I. The square root of 81 is 9. So this simplifies to 9i. You just put the number first, you put the I second. Now let's look at simplifying the square root of negative 56. I know that 56 isn't a perfect square, so I'm going to split this 3 ways. One of these is a negative 1. I'm going to take the negative out. I know that there's an I there. Then 56. How do we split up 56? 9. Nope, that doesn't work. 4? I think it's 4. What's 56 divided by 4? 56 divided by 4 is 14. Okay, the square root of negative 1 is I. The square root of 4 is 2. The square root of 14, we can't simplify any further. The correct order to write this, you want to write the number part that's not under the radical, then the I, and then the stuff that's still stuck under the radical. So 2i times the square root of 14 is the correct order to write that simplified radical. Okay, let's try number 3. Number 3, we have a negative 7 that we're just going to hang on to. Let's simplify the square root of negative 12. We're going to split this into the square root of negative 1. And how do we split up 12? 4 and 3. So we got an I, we got a 2, we got a square root of 3, and we have a negative 7. Okay, which pieces can we actually combine together? Which pieces can we multiply together? The negative 7 and the 2, that will give us negative 14. Then we write the I, then the square root of 3. As you get more familiar with I, you're going to be able to start showing less work. Like when I see the square root of negative 64, in my mind I think, hey, 64, that's a perfect square. The square root of 64 is 8, and there's a negative in there. That means there's an I. So the square root of negative 64 is 8i. Or you could say, let's do the square root of negative 20. I know there's an I in there. I'd split this up into the square root of 4 times the square root of 5. So it's 2i square root of 5. Because there's a negative in there, I know that there's going to be an I in the simplified answer. So as you get more familiar with these square roots of negative numbers, you're going to be more comfortable showing less work to get to that simplified answer. Okay, we can also use I kind of like X. So numbers involving I are called complex numbers. Complex numbers have real pieces and imaginary pieces. Standard form means that we are going to write the real part first and the I is going to be last. So the number -1 plus 2I is a complex number. The number 3 plus 3I is a complex number. In this problem, we are going to add those two complex numbers together. Well, really, this is kind of like combining like terms. The -1 and the 3 are both real number pieces of the complex numbers. -1 and 3 makes 2. The imaginary parts are the 2I and the 3I. What do you suppose 2I plus 3I is? Plus 5I. So those two complex numbers add together to give us 2 plus 5I. Now with subtraction, we have to be a little bit careful because we are subtracting this entire complex number. So we've got 2 minus 3I, that's the first complex number. We have to subtract the 3, and we have to subtract the -7I. What is minus a -7I? Plus 7I. Then you can combine like terms. The 2 and the -3 combine to give us -1. The -3I and the positive 7I combine to give us 4I. -1 plus 4I. Number 6, the first thing I would do is distribute the negative. So we have 2I minus 3 minus I plus 2 minus 3I. Now take a moment on your own, combine your like terms, and make sure that your answer is written in standard form. That means the I term has to be at the end. You should get -1 minus 2I. And I've gotten the question, what if I wrote my answer -2I minus 1? That is not written in standard form. Standard form means that the real part -1 is first, the imaginary part -2I is second. So you have to write the I part second. Okay. Next, we're going to start multiplying with complex numbers. And for the most part, I works just like X would. So 5I times -2 is -10I. 5I times I. Anyone want to take a guess what 5I times I is? 5I squared. Okay, now we need to talk about this I squared thing. Up at the top of the page, I put some rules. I squared is -1 because if I take I equals the square root of -1 and square both sides, the square and the square root will cancel each other out. So I squared equals -1. When we multiply, we need to remember that I squared equals -1. So anytime I see an I squared, I'm going to replace that I squared with a -1. So this term right here is really 5 times -1. What is 5 times -1? -5. So really, we have -5 minus 10I. Okay, number 8. We need to double distribute or FOIL, if that's the term you prefer. 7 times -1 is -7. 7 times 2I is 14I. -4I times -1 is positive 4I. -4I times 2I is -8I squared. Our next step is to combine like terms. We've got -7. 14i plus 4i is 18i. And what is this -i squared? -8i squared. It's really +8. Because this means -8 times -1, which is +8. So what I typically do when I'm doing these problems is I circle that term and I cross it out and I write a +8 above it or below it. So I know that that term really is a +8. That could help you to show less work if you wanted to show less work. So then our final answer is 1 plus 18i. All right, why don't you try number 9 on your own? So pause the video, give number 9 a try on your own. These are the 4 terms that you should get from double distribution. Anytime I see I squared, I'm just going to circle that whole term. That's -6 times -1, so really this term is a +6. Because then I can do the combining like terms all in one step. The -12 and the 6 gives us -6. The -4i and the -18i gives us -22i. Okay, if you haven't already started number 10 on your own, you can work on that. 6 times 6 is 36. 6 times -3i is -18i. 3i times 6 is +18i. And 3i times -3i is -9i squared. Whenever I see I squared, I want to address that first. So -9, excuse me, -9 times -1 is a +9. What else do you see when you're combining like terms in there? These two cancel each other out completely. So we have 36 and we have +9. Our answer is the real number 45. Do you see what's interesting about number 10 and how that middle term ended up canceling out? Do you see how it's like the difference of 2 squares? It's positive and negative. That leads us into complex conjugates. This isn't on your assignment, so we're not going to do this. But I do want to show it to you once. I is a square root. So can we have I on the bottom? No. So if I take something like this first one, 3/2 plus I want to get rid of the i's on the bottom. I'm going to multiply the bottom and the top by the conjugate, which is the exact same as the original statement, but with the opposite symbol. Because then when I multiply on the bottom, I will get 4 minus 2i plus 2i minus I squared. So when I double distribute there, I'm going to end up with those i's canceling out. This -I squared is really a +1 because -1 is +1. So really I end up with a 5 on the bottom. And then you would just distribute normally on the top. So that's how you get rid of a radical on the bottom when it's an I. Now this is not on your assignment today. I just wanted to show it to you once so that you've seen it. But that's how you use that difference of 2 squares, that complex conjugate, to get rid of a radical on the bottom. On your assignment, the first column is simplifying radicals with negative numbers. The second column is adding and subtracting complex numbers. The third column is multiplying. Number 44 in the third column, when you have 8 plus 3i squared, what does that really mean? That means you have 8 plus 3i times 8 plus 3i. So don't forget to do that before you multiply it out. Number 13, it's really just saying this first part matches up with 8. The second part matches up with yi. So